All right, let's go ahead and get started. We are going to be working through the second half of the modeling workbook today in class. And we've got our breakout rooms already set. And I think just from an efficiency standpoint, we're just going to assign one problem per group. I'll give you as a group a few minutes to break out and discuss your strategies and compare and contrast your individual notes and decide your course of action for presenting to the class. And we'll come back together and we'll present our best results from each group. And of course, we'll discuss as necessary. So we've got 6 different groups. I'm just going to do this in order, so there's no particular preference. Number 16, I'm going to give to group number 1 or room number 1. 17 is going to group number 2. 18 is going to go to room number 3. 19 is going to room number 4. 20 is going to room number 5. And the jackpot winners, group 6, room 6, you guys get number 21. So go ahead and work through your appropriate problem. Again, I'll give you guys a couple minutes in the breakout rooms, and then we'll come back together and we'll start talking about these. So let me go ahead and get that started, and then we'll get back together. All right, we're back together. Let's start working through the first problem. This is for room 1. I've got a couple people I've not heard from yet this semester, so we're going to ask Shashank Kavaru to go ahead and talk about what you guys came up with for this problem.
Yeah, Chris, do you want to? Okay, awesome. Wait, hold on, I'm trying to pull up the modeling workbook. Okay, so basically we just made the chart with the primary key being the course number, since that was what was underlined in relation to the entity on the ER diagram. And then we listed the other 2 attributes. And then we had the is prereq associative entity, which we didn't write it. We weren't sure if we were supposed to write that or not in this case, but we have it with the same relationship from course, optional many, looping back, optional many to course.
So the issue with this is we're not actually getting it diagrammatically showing exactly how the information is going to be stored for the course and for the prereq. So there's some information that's missing, and by removing the associative entity, in this case, you're back to a many-to-many relationship, which we know is a problem. So actually, in this case, this is not complete. Does any other group want to chime in with how you might add some additional information to this problem 16 to allow for that course ID to be both the identity for a course, but also a prereq?
Would you just add another table called prereq that has them all in there, and it links like that, course ID to course ID?
I would not. If you look at it, let me take a look at this problem. Maybe, let me see. Yes, I would. Sorry, I misspoke. Yes, you need some sort of other relationship which allows for the relationship between a course and its prereqs. And there's no way to do that without a separate table. So does anybody else want to show a diagram?
I can show mine if you want me to, because mine's kind of similar.
Yeah, you feel like you've got it. Let's see it.
We're talking about. Oops, sorry, I'm kind of moving between screens. Okay. So for this one, I made a separate one called prerequisite course, and my foreign key for the prerequisite course table is the course number, and then I have a new one called prereq course ID, and then we also have just the quantity of prerequisites, because maybe for this class it's an advanced one and you need 3 classes as prerequisites. I didn't know how to fully go about this, but it made sense to me.
Okay, let's talk about this one. So again, there's some issues here. The first issue I see is you again have a many-to-many relationship. And as soon as you have a many-to-many relationship, something is wrong, because we can't have those crow's feet pointing away from each other. The second thing is the course number over in the prereq courses, the course number needs to have a relationship with the course number, and the prereq needs to have a relationship with the course number. So we're actually missing a little bit of information there as well. Third thing, quantity of prereqs is a calculatable field. I could look under the prereq courses and I could count up how many times a course number shows up. And that is how many prerequisites it has, because it would show up, the course number, that first one would show up 3 times or 4 times or 7 times. And that's how many prereqs it would have. So I wouldn't store it in the table as its own column. It'd be something I would calculate after the fact. So again, I'm really glad I saw this example, but this is not quite what we're looking for. Does anybody else want to take a shot at this? And by the way, obviously, for the folks who have shown it so far, thank you. I'm not trying to scold you. There's nothing wrong with not getting it right the first time. That is the entire point of doing this together as a group. So I really appreciate your participation. Anybody else want to take a stab at this?
I have one that looks similar to what you were describing.
Let me see. There we go. I love this. Let me describe it. I'm sure that she could, but I'm going to go ahead and talk about it so that we get exactly what I want to describe on video. So in this case, we have our parent course entity, which has the course number and then has a descriptor, which is a course name, and then some information like units. Over in the prerequisite, it is basically an associative entity, but it's an associative entity between a table and itself, which seems a little bit weird. But think about it. If you actually drew course, the course table on one side, and then course over on the other side, which doesn't make sense. You wouldn't have 2 separate entities, but pretend you did. The crow's feet would be pointing in to the associative entity, not out. They'd be pointing in, and that's what we want, is there be a one-to-many into the associative entity and a one-to-many into the associative entity from the other side. And that's what you need from a relational standpoint. So you don't have the crow's feet pointing away from each other, you have them pointing towards each other. And in this case, the course number can show up as the course number for the prerequisite table as many times as it has to. So this class could show up in there 4 times because it has 4 different classes that are going to be prereqs for it. And then the prereq courses could show up in there as many times as necessary. And what is unique is the combination of the course number and the prerequisite course number. And technically speaking, the symbology, there's just the smallest issue with symbology that I have here, which is that I would have foreign key and primary key here as well. Because what is unique for the primary key is the combination of a course number and a course number, both of them together. That would be a primary key. They are both foreign keys someplace else, right? If I said to all of you, 313 has 2 prerequisites, ISTM 210 and ISTM 211, you would know exactly what I'm talking about. You'd be able to go over and look in the course table and look up what 210 is. You'd be able to look up in the course table and look up what 211 is. The combination of 313 and 210 is unique. The combination of 313 and 211 is unique. It's the combination of those 2 things that's unique. And then if I said count up the number of times 313 showed up in the prerequisite table as a course number, not a prerequisite, but as a course number, you'd say, aha, 313 has 2 prerequisites. They're 210 and 211. You could do that math. So going from our earlier diagram to this seems like it shouldn't be that hard. Turns out that it's kind of challenging. So I really appreciate everybody that gave this an attempt. I hope that this final version makes sense to everybody in terms of what we're trying to accomplish. But definitely give it some thought. And if you have to, go back and watch this video, which I'll post on YouTube, and work through this one again. This one is definitely an interesting problem. Thank you for sharing. I really appreciate it, everybody. All right, let's look at problem 17. I got one more person that I have not heard from that is in group 2, Shayar Sudadenya.
Yes, sir.
You are up.
All right, can y'all see that?
Yes.
Yes. Okay, perfect. So we've got the course entity with a course ID, course name, and that's the right one. Yeah, and units. And the primary key is the course ID. And then got that going over to the section where the course ID is the foreign key. And then the combination of section number and section ID is the primary key. And then in terms of the kind of the semester information, wasn't 100% sure on that part of it. That's where I think it gets shaky. But I've got a semester table as well, where that's the primary key here, but also the foreign key based on that connection.
So this looks pretty close to what I would be thinking about, but I'm certainly willing to hear from the peanut gallery. The biggest concern I have is this. Because
Okay.
if it is truly a mandatory one on both sides, if it really truly was that, then I would just merge these two tables together, because semester would have to show up exactly one time and only one time only in the section table. And
Right.
as a consequence, there's no reason to have it as a separate table.
Okay.
So I don't think that's what you mean. I think what you mean is that the semester ID could show up over in the section table for every single section that was ever created, right?
Right.
You'd see it show up a bunch of times for a lot of different sections. So I think
Right.
you mean that that is
Be a one to many.
a optional menu.
Okay.
It's possible there's a semester where no classes are offered. That would seem strange, but it's possible. But
Yeah.
you're likely to see a semester show up a bunch of different times. Yeah. Anybody else, any of the other groups have anything they want to add or a different approach to this problem you want to discuss, want to share with the class? Because I'm happy to take a look at it for sure.
I'm still just a little bit confused on the semester ID and the semester table,
Mhm.
with the primary key and foreign key being applicable to the same thing in the same table.
Say that again.
So for semester ID in the semester table, it says it's a primary key and a foreign key. I'm just a little confused on that concept.
Right,
Still,
so-
that's fine.
That is not correct. Over in the semester table, thanks, I didn't catch it. Over in the semester table, the foreign key you'd want to get rid of because it's not a foreign key.
Okay, so it can only either be a
Yeah,
primary key.
and what you'd want over here is you'd want to add it as a foreign key. The many side is going to get the foreign key. Think about it. If it can show up a bunch of times, it can't be unique. So it's got to be foreign key someplace else.
Okay, so then I guess what he was describing with the semester ID and the section number combined being the primary key, then how would you show that now in the section table if that's a foreign key?
So in the section table, the unique identifier, I think, should be the course ID and the section number and the semester ID. Because it would be, if I think about it, I teach ISTM 250 is a good example. ISTM 250, section 501 for spring 2021 is unique. Because I also teach ISTM 250 in fall of 2021, and there will be a section 501. So it's the combination of the course, the section, and the semester where it's being offered, which is a unique primary key. So again, here, I think you want this, which is a foreign key, to be, I think, also the primary key.
So, okay, but you're combining all three. So I guess
That's right.
how do you indicate that? Do you put primary key in front of all of them?
Yep. So this one should see primary key, comma, foreign key. The section number should be just primary key. It's part of it. And the primary key, foreign key for semester ID. It's beautiful.
Oh, okay. So that's how you get the primary key foreign key combo is when it's part
Correct.
of something table. That's
All
true.
that foreign key is indicating here is if I go look up this course ID over in the other direction where it's pointing towards the one, I will find it. And I will only find it one time and I will tell you all kinds of things about it. If you tell me the course ID, I can tell you the course name, the course description, the instructor, the whatever, all kinds of things about the course, because I can find it in one place, which is the course table, and find all the unique things about it. Similarly, if I go look up semester ID, I can go tell you the semester and the year that are associated with semester ID. But inside the section table, semester ID is going to show up a bunch of times. Course ID is going to potentially show up a bunch of times. Section number is going to show up a bunch of times even as well, right? Because I teach section 501 and 250. I also teach section 501 and 468. I also teach section 501 of this course, it's a single section. So those numbers will show up a bunch of times as well. It's the unique combination of those three things that would not show up more than once.
Okay. Thank you.
Maybe
Yeah.
I just spaced out for a second, but I've been holding on to this question for a little while.
Hit me.
So I guess I was a little bit confused or just wanting confirmation on why we're creating what looks like an entity out of like a primary key that's like an attribute. Is it because the attribute that's a primary key has two things coming off of it that we're
Exactly,
creating
because the
this?
semester is kind of this combination of semester and year. He did it as a separate semester ID with the semester and year. Now, do you have to do it that way? Not necessarily. If you wanted to just code semester ID as spring 21, fall 21, winter 21, spring 22, fall 22, summer 22. If that was some sort of combined field as the unique identifier, then maybe it's not a separate table. But I kind of like the idea of having this sort of separate thing which controls what are you allowed to type for semester ID. And as long as you have some sort of control mechanism for that, whatever it might be, I think that that works well from a database standpoint. So if you as a group or as an individual didn't have this table over to the side and you just had semester ID as part of the primary key in the section table, I'd also be okay with that. But I think that the way that this was done actually is a little bit more robust, a little bit more control oriented, which I do like.
Okay, cool. Thanks.
Yeah, of course. Great question. Anybody else? Good on this problem? Okay, great. Thank you. All right. I'm going to do some randomization here and call on somebody from room 3. So give me just a second. It's going to take a minute. Let's call on James Warman.
Did you say my name? Sorry.
James Warman, is that you?
No, that's me.
You are up for presenting the next question.
All right, perfect. We're going to be using Allison's. Hers was by far the best, so that should be popping up here. Alrighty, so as you can see here, we have employee and the associative entity in the middle, and then with project on the right, with employee ID being the primary key. And then on the right side, looking at project ID is the primary key, while employee ID is the foreign key. And then on the associative entity, you can see here that employee ID and product ID come together to make the new primary key for the assignment, which has billing rate attached along with it.
So for the project, why is there an employee ID over in the project table?
So since this one's mine, and that's kind of like more so my thought process on it, and I should have gone over the notes more before I kind of went on this, but I got the feeling that if there was an optional, that sometimes you had to have the primary key from the connected table as like a foreign key. I don't know. I did struggle with this a little bit.
I don't think that you need that. In fact, I do. I am positive that you don't need that. What that would suggest is that there is a single employee associated with the project. Now, if the way the problem initially read was, there is a single employee, which is the lead employee on a project, that row would be perfect. And you'd still have a link between employee and project. And it would be a 1-1 on the employee side of things and a 0-1 on the project side of things, which would say an employee may be the manager of a project, but may not be the manager of a project, but a project absolutely has a single manager. The problem doesn't say that, but that's what that would suggest to me. If I was just looking at this diagram and I didn't know what the problem description was, I would have looked at that row and said, aha, what you're suggesting is that there is a single employee who's the manager for the project. There isn't, but that's how I would have modeled that. And then I would have had to draw an additional relationship, of course. In this case, what's happening in the middle is that combination of employee and project. each project can have one or more employees as part of the project, and that's all getting filled in that center area in that assignment where you're doing the combination of employee and project. And then you're adding some additional information for that specific combination of individual and project. What are we billing? Or what are they charging to be participating in that particular relationship?
Okay.
The,
And just
the
from, like, a
cardinality looks good to me,
curiosity.
right? Projects don't, I think probably projects have to have employees assigned to them. So maybe that optional many should be a mandatory many. I think that probably a project has to have at least one employee working on it, but maybe not. Maybe you create a project first and nobody started working on it yet. So I would, you don't have to change it. That's fine.
Okay, I was just going off what was already put in the thing. Is
Right.
that incorrect to?
Yeah, and that's why I'm saying, like, I see that in the original diagram. You just follow the diagram, but you guys could argue, right? Like, does a project exist if nobody's working on it? It's the tree falling in the woods and nobody's there to hear it. I'm not sure. So that's fine. We're not going to change that. But if somebody said, "Yeah, I don't know about that. Why is it like that?" I could see where you'd argue for a one many. Other than
And
that,
if-
I think everything here looks pretty good.
Would it be correct or incorrect if instead of having these in like a combined, that I had primary key, like the project ID and this one below, and there was an
right.
extra row?
Symbolically, the way this table should be organized in the center is employee ID should have a row to itself. It's integer. And next to it, it should say primary key, comma, foreign key. Project ID should have a row to itself. It's also type integer, primary key, comma, foreign key, right? Both of them individually are foreign keys to the tables to the outside.
I
And
see.
both of them combined together make the primary key for the assignment.
Okay, I'll change that. Thank you.
Yeah, easy symbology change, but the general structure here is good. Good, great. All right, let's look at somebody else here for the next problem. That was room 3. So room 4, William Mitchell.
We'll use Michaela's
Okay.
if you want to throw that up there, Michaela. So going back to question 5, we kind of diagrammed it a little differently, but we have our owner, and we have the name of the owner. We have what they own, and then how the property ID is then related to the sales office. So you've got an office and you've got multiple property IDs associated with each office. And then you have an employee that's associated with an office. And that's kind of how that links there.
So you're
Michaela,
missing
I
some
know this
arrows.
is-
Yeah,
What was that?
you are missing some arrows.
Mhm.
So we're going to do this symbology. You'd want to have an arrow from the property ID to property ID, and you'd want to have an arrow again from the primary key to the foreign key for owner as well. If you have an entity in these diagrams that does not have a connection to any other entity, you have to ask yourself how it is participating in the database in any way. These are relational databases, which means every entity should have at least one relation with another entity. So if you don't have some sort of connectivity, you need to be wondering about that a little bit. Yeah. Other than that, it looks like you've got for sales office, what is it? Office number and property ID. So is that a composite primary key for the sales office?
No, I had property ID just as the foreign key because that's, yeah, I wasn't totally sure when I was doing that.
And sorry, I
That
drew
should
those
be there or not.
arrows in the wrong direction. Let me draw those back again. You're supposed to be drawing them. I drew it the wrong way. From the foreign key to the primary key. Yeah, is that right? So it'd be that direction, and it'd be this direction. but to this, to the property there like that. Yeah, I don't know about sales office and the property combination there. That doesn't quite look right to me. Any other groups want to chime in and talk about what they did? Or any other individuals? I'm not going to give this one away to anybody. So if nobody else wants to chime in, we're going to leave this problem a mystery for you guys, which I don't think is a good idea. So does anybody else want to contribute what they did?
I'll share mine.
Okay.
So
Go ahead.
it's a little bit different because I have the two connections between sales office here. Otherwise the order is pretty similar to what their order was.
Yeah, so it looks like owners participate in effectively an associative entity, which is owns, and property participates in the associative entity, which is owns, right? So the combination of an owner and a property makes up the owns associative entity. And if memory serves, I think there might be even one additional field for that one, which is the percent that they own. I think for the table, the own table, not the owner's table, but the owns table. Now, next one, not that one.
Oh, okay.
I think that one would have like percentage ownership was one of the things they talked about, which is not something you can easily calculate. Again, it's been a while since we looked at problem 5, but if my memory is right, I think there was a percentage ownership. And there would have to be some additional logical rule there too, that would say like percentage ownership has to add up to 100%. And that would be something outside the scope of these diagrams. For properties, you can see that the office ID is linked to property, and that can show up more than once, right? Multiple offices could belong to us, could manage a particular property. But in the other direction, a sales office or a particular property only has one sales office managing it. And at most one, and at least one, you have to have a sales office that manages the property. So we have that relationship between property and sales office. She has two relationships between sales office and employees. And that is because there is an office ID for every employee, because every employee belongs to exactly one office. But there's also exactly one manager for a sales office, which you have to link back up to employee ID. So there are two links there, and it's kind of hard to tell in the diagram, but one of them is, yeah, they happen to be crossing paths. One of them is basically this direction, and one of them is basically this direction. So the office ID to office ID is a one-to-many, where the office can show up in lots and lots of different employees, lots of different people working in a particular office. The employee ID to manager ID is an optional one-to-one in one direction, where every employee doesn't have to be a manager, but every sales office has to have exactly one employee as their manager. And that's how she's managing that. Okay, so let's take a look at the primary key, foreign key symbology, because I sometimes am missing those, because I think we do have a little bit more information we could fill in here. Specifically, I think there's only one. I think that maybe not, maybe she's got it. Let's see. No, that's correct. Everything looks right to me as far as the primary keys and the foreign keys. So it's a unique identifier for sales office. It's not composite. In fact, none of them are composite except for the own table, which is an associative entity. And associative entities will usually have a composite primary key between the two tables they're connecting. And maybe more, but at least the two tables they're connecting. This looks pretty good. Does this make sense to the previous group in terms of being a little bit more robust, managing the kind of data we're looking at, I hope? This was good. Thank you very much for sharing this one. I appreciate that. All right. Are we ready for the next one? This was going to be group number 5. Let's take a look. Michael Grogan. Or Clay. Sorry, Clay, are you here?
Yes, sir. Marissa, can you share it? Sweet. So we have the painter one. So we were kind of confused on how to do the referral ID for the customer. So we just did a referral ID, and maybe like if they didn't have a referral, it could be like 0. But then we have the customer ID connected to the job. And then we didn't do the one-to-many relationships on here. We just did arrows. And
That's
then
fine.
the job ID we connected to the painters, and then the employee ID also connects to employees. And we also forgot some of the other like little.
So for the referral ID, it is basically just a kind of a cyclical control where it's kind of pointing back to itself, because the referral ID would have to be a customer. And if you were using the crow's feet sort of thing, pointing back to the referral ID would be a many side, and going back to the customer ID, no, sorry, optional 1, and going back to the customer side would be, no, the optional 1 to the customer side and optional many to the referral ID, I think. Is that right? No, optional, I gotta get this right. Optional 1 to the customer and optional 1 to the referral ID. You don't have to have a referral. If you do a referral, it's going to be one of the other customers. But that one's it's a tangled mess, right? That's kind of confusing when you have this optional 1 from one table to itself. So that's kind of a challenge as far as how that stuff works. And we will talk about when we finally get to SQL Server and programming these databases, how you program that thing. That's a little bit of a mess. But you are missing some other information, right? There's some other stuff here that you're supposed to see.
Yeah, so like their social security number, which would be like an integer, their name, which would be a text.
But those are just additional fields that would show up in either employees or customers. They're not critical to the structure of the data, I think. Has anybody got anything else as far as this diagram that is structurally significantly different and want to share and we can talk about? You guys are very, very quiet today.
The only thing I did differently was I did another referrals table like I did for that previous question that I had with the semester.
Will you share your diagram with us so we can talk about it?
As long as you ignore the rest of what's going on, because there's definitely some wrong stuff. But I just went ahead and did another referrals table down here, linking the customer IDs.
So what this allows for is a customer could have a bunch of different referrals. And that's not the way this problem is written. That is certainly reasonable in a real world situation where you might say, who referred you? 3 different people on my street referred me to the same plumber. That's a possibility. That's not what this problem says. What this problem actually specifically says in the text is, if you have a referral, there can be only 1. So this technically would not be correct. It allows for something that is not allowed in the business rules of this problem statement. So I'm glad you did it this way because it's worth talking about, but I would not want this to see this from a diagrammatic standpoint. Instead, I want 1 additional row in the customer table, which is who referred you, and it's got to be one of the previous customers that referred me. And I'm ignoring everything else because we can see there's some other things that aren't right there. But yeah, that's the big ticket item as far as referrals is, can they have more than 1? If they can, what you did is right. If they can't, then what you did is not right.
Gotcha.
So think about one of the reasons why we did things like associative entities in some of these problems is we're trying to manage this one-to-many scenario where if I'm a student and I want to list all the classes I'm taking, I can't do that in a single row that describes me as a student. There's no way to do that. But if I want to list just one thing about something else in my row of me as a student, well, I can do that in the same row. So if it is, I want to list one referrer and only one referrer, well, that could probably be a column in my table about me. If it's, I want to list more than one thing, well, it probably can't be a part of the row of the table about me. And that's a pretty good clue as to how that's going to work. If it is truly a one-to-one, it's probably a new column that is a foreign key to someplace else, and it is either an optional or a mandatory one relationship with the other side. So that's a really interesting problem, and I'm glad we had an opportunity to kind of illustrate how that might work. Any other questions on that problem? Everybody's okay? Everybody make an excited face. You're so enthused and happy about what we're doing right now. Yes? No, I can't even get people to nothing. Well, let's look at one more problem, which is the big one, the big kahuna, problem 21. Who am I going to pick on for group 6? Rishi Subramanian, you're up.
Hello?
Hello.
Okay, yeah, I think my video thing is frozen, but I think we worked on Haley's, so if Haley could just screen share. Okay, I'm just gonna stop the video. But yeah, when we looked at this problem, we weren't really fully able to finish it, but it starts off with the conductor, and we have the primary key as the conductor ID, and it has a one-to-many relationship, an optional relationship with concert. So we connected it there, and then conductor ID and concert number were the primary keys here. And then going up, we had concert season, which I was a little bit confused about, but the primary key over there was the opening day, and the foreign key that we moved up was the concert number as well. And the relationship for that was a one-to-many. And going down, when the includes, which is the weak entity, we have concert number and composition ID as the primary key and foreign keys. And as we keep going down towards composition, we weren't able to fully finish and understand.
Okay.
But on composition ID particularly, that was the primary key, but we were unsure on whether to add movement number, movement name, or just movement ID. And we weren't sure if it was the text or integer, but going to the left on performs, we have the soloist ID as a primary and foreign keys. It connects through concert number, which is the primary key for composition, and composition ID as well, just to connect it to the concert. And then soloist ID in particular has 2 more entities. And the primary key for that is the soloist ID, which is integer, and then soloist name would be text.
Okay. Yeah, this one's, I mean, obviously it's a really big problem to start with. And there's some confusing stuff. So for instance, that concert season, it suggests that the unique identifier for the concert season is the opening date. I think based upon our discussion in class, we would say that that is a terrible unique identifier for concert season, right? Because dates are kind of this malleable thing. So it's probably not a great identifier, but that is what the diagram is giving to us. So you guys are modeling based upon what the initial diagram gives. And that's all I'm asking you guys to do. But I think that one of the reasons you might be looking at it and going, not crazy about that, is that exact reason. I don't know that you would have the concert number in the concert season. It's the other way around, right? If the concert is part of a concert season and only part of one concert season, what you'd want is you'd want the concert table to include the concert season's unique identifier as a foreign key. So again, what we're talking about here is that this table, which is on the many side of the one-to-many relationship with concert season, would get an additional row. Yup. It would be opening date. And that would be a foreign key, which points to the concert season. So a specific concert is part of a particular season. And which season is it part of? It's part of the, and you don't have to draw the additional relationship. You already have it, I think. Oh, I guess you had it connected with concert number. I see. Yes. So you'd want to move that one. Okay, so you'd remove concert number from the concert season and you would instead go kind of the other direction on this one. And again, think about how you would type this information in a table. You'd have the concert number, the concert date, the conductor ID, and you'd say, well, what season was this? Well, this is the season that started on March 1st. Well, you'd be able to type that single entry in the concert table, and then you'd know everything else about that concert season. It started March 1st, the theme is Mozart, blah, 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 whatever else there might be about concert season. Okay. Let's talk a little bit about the composition and the includes. And again, I'm kind of going back to my notes on this one as well. So for the composition, you've got the composition ID, and then you've got this movement ID. Well, movements would have to actually be a separate table in and of itself. If you look at the way the diagram is in the instructions, the movement ID is actually that double circle, which means that it's a descriptor or an attribute that is actually multi-attributed. So we'd want that as a separate table off to its side, which would be the movement ID, which also had the movement number and the movement name. And then you'd link it back up to the composition by also adding the composition as a foreign key in the movement table. So even though it's not drawn that way, you would have to have a separate table. You don't have to do all this right now, but just think about how the movement table would have composition ID and then movement. They show movement ID in the diagram, but really it would be the movement number and the movement name. And that makes up the movement ID. Okay, so that would be a little bit separate. And then you could remove movement ID from the composition ID table. The composition ID table has also that composition ID, which has the composer name, and the composition name is kind of that combination of composition ID. I think you could just put those in as attributes for the composition ID. You could also add two separate attributes, which would be the composer name and the composition name. That should be totally fine. They'd be attributes that are associated with composition. I don't think they need to be off of composition ID. But they're suggesting that if you combined Bach movement 4, or Bach, sorry, arpeggio, that would be the unique ID. I'm not crazy about that idea. I think you could make those as just separate columns in that table, or separate attributes in that table. And then you can see that concert and composition have the kind of the crow's feet that are pointing away from each other. And we know that we don't like that. So we'd want to have some sort of associative entity between those, which is that includes, which you guys did, which is great, right? The includes has to be the associative entity, where a particular concert includes a specific composition ID. That's fantastic. I love that. Moving over to the performance side of things. Again, you can see the crow's feet pointing away from perform, so you guys pointing them back into the associative entity for performance. Performance is going to include the last date that things were performed, the particular solo, and the particular composition ID. And then you're linking that back up to concert. I don't know. You know, that's a tough one as far as the concert and the composition and the soloist and how it's drawing, all those sorts of things. So I'll tell you the truth. What I would have to do, and we may come back to this problem later, is I would have to try to put this into a database and see if that actually behaves the way I want it to. It's a complicated model. That's basically a ternary, T-E-R-N, ternary relationship. And those are always really challenging to model correctly and get them to work in a database. So the performance part of this, I'd want to see it in a database itself and kind of just muscle it and see if it actually works the way we want it to. It might, but I want to see it. And that's where you've got 3 primary keys, which are all separate foreign keys as well. It's that three-way relationship. So good job to room 6. This is a hard problem to model for certain. And you guys got pretty close on it. So good job. I'm impressed by that. All right. That is the remainder of this workbook, which we blasted through in an hour, which is pretty darn impressive. Obviously, I think everybody should go back through this on an individual level and make sure that you as an individual can draw these diagrams correctly. So you can always go back and watch this YouTube video, but better yet would be going back to these problems yourself without any notes and seeing if you can draw these diagrams based upon the descriptions. That would be good practice for you. Now, let's talk a little bit about our schedule moving forward. Last week, we were supposed to not meet on Tuesday and then meet on Thursday, and instead, nothing happened because of the weather that we had. So this week, I got to see you on a Tuesday, but I'm not going to see you on a Thursday. I'm still going to give you a day off. I'm not including last week. We're going to pretend last week never happened. So this Thursday, we do not have an official class meeting. If you as groups want to get together and discuss what you are going to submit for next Tuesday, in terms of your visualization, Thursday would be a good time to do that, right? You know that all of you should be free from 1:30 until 2:45 to discuss class. And since we don't have class, it might be a good opportunity to get together as groups and figure out what you're doing for your visualization project. On next Tuesday, we're going to do a couple things. If you look at our schedule, you know that we're going to do our visualization project 1 on Tuesday. That's due on Tuesday. And then we have an exam on Thursday. So everybody's going to have submitted their phase 1 project. And then I'm going to ask every group to present to the rest of class and me what you're thinking about. This doesn't have to be a super formal presentation, but just a brief discussion for 5 or 10 minutes from each group on, hey, this is what we're thinking about doing, so that I can hear it and I can provide some feedback. But also, if anybody else in the class wants to say, hey, that's an amazing idea, and I might be able to point you in the direction of somebody who knows about that. I've got a friend who works in that industry. We can do that. We can actually do some collaboration. So we're going to spend half an hour, 45 minutes next Tuesday discussing what you guys are submitting for your visualization. Oh, do we not have class next Tuesday? Is that true?
Yes, I actually just pulled it up to check.
Oh my goodness. Well, that's no good. Well, never mind. I guess you guys have something to do and we'll have to talk about it the following Tuesday. I didn't realize we actually had a holiday during the semester where we don't have class. Okay, well, then the second part of this will be that I'm going to review for our exam, which is absolutely happening, not this Thursday, but next Thursday. What I will do for the review is I will basically go through the material we have and talk a little bit about what you can expect for the exam and answer any questions you might have. We don't have class, so I guess we'll do that either next Monday or next Wednesday as an optional meeting. And I will record it and I will post it on YouTube. So if you can't make it because it's outside of normal class time, then so be it. I don't want to interfere with the holiday, so I'll give people off next Tuesday. I'm thinking out loud here. I'm going to be thinking outside the box. Maybe we should review this Thursday. Is that okay if we actually do meet this Thursday so that I can give you off next Tuesday instead? I'm going to assume every single person is nodding their head enthusiastically. Okay, this Thursday, we will review for the exam. Next Tuesday, you have your visualization due. I'm not moving that due date. We'll talk about it after the exam. That's no problem. We've got plenty of wiggle room in our schedule. But this Thursday, we'll do a little review for the exam. We'll talk about it. I will record it. I'll post it. And then next Tuesday, you guys will have the day off, but I'll be looking for your submissions that day. And then next Thursday, we'll have our first exam. If you can't find the YouTube channel, you have not looked on eCampus or the syllabus particularly hard. And wow, we're a month and a half into the semester, so go do that. I'm not going to point that out to you. You can go find that stuff. Definitely use your resources. There are all kinds of places where you can find that on eCampus and in the syllabus. Any other questions for me? Thank you guys so much for your hard work today. I really appreciate it, especially the people that shared their diagrams or were willing to discuss incomplete answers, that's absolutely fine. And the fact that you have the courage to do that, we can talk through it as a group, is really, really good for everybody. So thank you for doing that. I will see you guys on Thursday, and we'll talk a little bit about our exam for next week. Thanks, everyone.